Hey guys, this will be video 4 for the how to design build a 58 Explorer replica out of Korina, or this is called black Limba. You can also get blonde Limba as well, or blonde Korina. But this is the first black Korina guitar I've ever built, or Limba. So anyway, it's really beautiful. It's very vivid. It's almost wild. And I had mentioned in one of the early videos, there's a part of me, I was kind of tempted to sample doing a hand rubbed oil finish rather than a nitrocellulose lacquer, or at a minimum just doing a French polish where either you could use shellac and actually French polish this thing, because it would be really beautiful just to see it without any shine, right up to the point to where when I machined this, it produced some really beautiful flame right there, but right up the point where it's not really of any value because it's not on the player's side. When I machine this, if all of a sudden I saw this unbelievable beautiful flame present itself right there, then it might change my consideration as to how I'm going to finish a guitar. But and that's just woodworking. You really don't know what you're going to get until you cut into it. And why is it flaming right there more than it is over here? Well, it's not flaming over here at all. It's flaming over here because of the quarter. Yeah, because see, it's rift sewn like this. So when you flip this over, when you're looking along that direction right there, you're looking at a perfectly quarter sewn portion of that neck. And that's why your target should be, when you're building a neck, is to try to have perfectly quarter sewn wood, so that when you do your machine work, you're getting flame here and you're getting flame or figure consistently. But as Benedetto said, if you can get it on the player's side, it's even more valuable because that's what they see. I mean, that's what you see, as you're playing the guitar. So anyway, let's talk about the next operation, because this was obviously S4S, and I had to come in and either sand and scrape and chisel and all draw knife and all that crap, or just put this on a jig and make about 5 passes as I lowered the bit down into it, which is exactly what I did. And it took about 35, 40, no, it probably took about an hour to set up and get the router station set up and the vac system and all that stuff. And maybe an hour and a half, 2 hours for the whole operation. But it's more enjoyable, and also it's more precise, much more precise right out of the gate. And I'll talk about this briefly. When you are machining this, let me think. Should I go ahead? Yeah, let me stop, because I've already done this video and I had to erase it because this was exactly the direction I started talking, and I did not have the jig in place to show you what it was I was even talking about. So let me do this. I'll just get it on the table, and then I may pause while I set it up. And in case I forget, well, I won't forget because I'll be talking about the router. Okay, if you had something like this, like a neck length, see, look at that flame. That's amazing how beautiful that is. I hope you can see that. That's Honduran mahogany. A little bit, no, it's got beautiful. So this would be an unbelievable neck. I got this board for $20 because it has a nasty split right there. But the cool thing about this is I'll be able to get 2 necks out of it up here without any split in it, and then I'll be able to get a 3rd neck where I would be gluing that back together, and then that might be a paint grade neck. But this is Honduran mahogany for neck material, quarter sewn, and this is something that you could use as a base for your actual router to ride along as you're doing this heavy duty route work. Okay, it doesn't have to be this. This is not how I do it, but I'm going to be clamping this on here and then showing you how and why I would recommend routing the treble side of the neck first, and then we'll flip it over and re-clamp it with our cabinet clamps and do the base side last. Okay. So let me do just that. Let me go ahead and just clamp this baby up, and then we'll talk about how to do this job. Let me pause and do this off camera. Okay, so that's the initial step, just clamping to something really nice and true, because the most important thing is that you've got a nice 90-degree angle right there. When you roughed out your neck out of the initial material, you'll have a drop left over from where you were doing the rough out of the S4S board, and that will already be at the appropriate pitch or real close enough that you can clamp like that and use a cabinet clamp. These don't have crushing force on them, but if I were going to put a little bit more pressure, I probably would have something under there to protect it. But the whole idea is that you're wanting to get ready to, now you see the importance of extending your base. I have a lot of control over that router with just a single hand operation, as opposed to. I'm not saying this would not work, but this is such a large bit as you're going into this operation. You don't have much control. You don't have much uh, extension there. So build yourself an extended base. Cost you about $3, maybe $10 for material. Real simple. It's not dimensional, but it is true and square. And the most importantly, it's 3/8 of an inch thick. It's real stiff. And this is really incredible for it when you're routing, and almost necessary if you're building the Explorer body. I'll go ahead and talk about this briefly because this will apply to making certain that you keep control of routing your neck. And if anything, if you're thinking, I can probably pull it off with this because I don't want to spend that $3. Well, when you're trying to machine around an area like that, you literally have no footprint with a traditional base. But with my design here, I've got complete control of this. I hope that's in the camera. Yeah, that should be in the camera. This ought to be a really great video as far as keeping you safe and also keeping you safe from tearing up your wood, not losing your wood. But if you're doing a pushing cut with my left hand, I've got complete control of that router the whole time as I'm going way out there and cantilevering out on the edge and doing all that work. And it just keeps the stress down as well. So. Okay, so, and that would work right there. That would be sufficient, even without any sort of additional material over here, because since you've already machined all of this material here, you don't have a flat surface here anymore, which I'm not going to say it's necessary, because with a base this large, I can do the same thing. I can kind of go in like this and then run this all the way down to a stopping point down there. That'll be fine. And if anything, that might be a simpler jig to build and a simpler operation, because the whole idea is all you're wanting to do is make certain that you can, this is not a one cut pass. Obviously, you're going to be easing down into this. And I typically make about 7 to 8 passes. And because you're doing the treble side first with your S4S material, you can just about do this blindfold and know that your bearing is going to make contact immediately, even if you're all the way up here. And then as you go into it, so your bearing is going to be making perfect contact, even if you cut all the way down flush till it's a sharp edge, because you've still got that flat right there all the way down the line. Okay, so route the treble side first, and then we'll talk about our reasoning for that once I flip it over on the other side. But the way I've got my jig designed, I've got an additional 3/4 inch tall plate that goes up here, and it's it actually goes beyond the neck, up there. Not that I really need it, but I do in the event I wanted to turn. Yeah, probably it would be wise to do that. In the event I want to turn the router and look down visually and make a visual cue as to where I'm stopping. If I don't have a block up here that guarantees that I stop at a certain location, it'll be game over if I go too far and cut into that, headstock and tear it all up, especially if you're doing clear coat guitars. Always build your guitar as though it's going to be a clear coat, even though if you know you're going to paint it, and that'll just get you in the habit of building your jigs so everything's very safe and functional. You didn't just have a jig like this that stopped and then you got over here and you ran the risk of tipping or something like that. So it'll go all the way down here and it'll go all the way down here. Let me back up. The whole reason for having this step is to allow me to continue on, because keep in mind, most of the headstocks that I'm building, they're the jazz guitar, they're the big wide jazz guitar that is immediately projecting out right there. And if I didn't have that raised platform, I was having to stop back here and then having to hand shape every bit of that, which is not that big of a deal. But I just wanted to cut as much as I could on the very front end, and I learned my lesson that since this router bit is obviously going beyond the neck, you couldn't take this all the way up without making contact. So you step this back about 3/8 of an inch, and that gives somewhere for room for the router bit to run and not make contact with the upper jig. The further you get back, the more you're cantilevering. So, don't go back too far, but just know that if you bring it up, let's say you took it up to 1/4 of an inch, just know that you're going to make contact. And that might be okay because you can monitor it as it's going down. But in case, well, I won't forget because I just thought it, the absolute most important thing in this whole operation, especially if you're working with a dark wood, make certain that you identify that top, especially up here. You want to identify that top ledge right there, because what is that? That's the guitar. You miss that, you lose the guitar. Or if you're scared and you don't go far enough, well, then you ended up with a fat neck that actually needed another 32nd of an inch material taken off, that now you got to shape all that crap by hand. The whole idea of this build right here is getting very, very close to the finished neck with a 1-inch radius bit. That's pretty hard to do by hand. Obviously, most of them now are all done with a CNC machine, but what is a CNC machine? It's just an intelligent machine that is based on a computer program that tells it when to stop on the XYZ axis. And God gave us an arm to do that and a mind and eyes to do that ourselves. As long as we got a good base, we are the CNC machine. So, all right. So on that note, I'll stand that back up so it doesn't fall. So you got that. So you got that platform up there, and you got all that under control. Now the whole idea is once you get back here, well, you didn't achieve anything because you're now having to do that real extended cantilever. So what I did on my design was it's not square. I actually radiused it, but all you basically would do. I don't know if I do have a square block. Oh, this would be perfect for the video. That's all you need right there. You could actually permanently glue that together, and don't temporarily glue it because you don't want to risk any of this crap right here. You want that to be a perfectly flat surface once you're right. Well, actually, on this side you're going in right here. It's guaranteeing that you stay perpendicular as you're cutting. But basically, all you need is something to support the router base when you're entering in from back here. Is that on the camera? Yeah, that should be excellent as far as being in the camera. So that your bit's way out here, but your router base is exactly what I just showed you. It's very well balanced and cantilevered, and it guarantees that when you go, honestly, I'm not kidding you, I could just about do this blindfolded because you can feel it so well, and there's so many guaranteed stop points or start points that you're it's just a safe operation. Okay, I hope I didn't ramble through that too much, but just know that you'll have a real nice solid base. If you don't have a large piece of mahogany like this, you could go with an exceptional piece of like a 2x8 material from like your big box hardware store that's maybe very, very true, very tight grained wood that you know is not going to warp on you, or maybe buy several pieces of poplar and laminate them together. That would be a very safe move where you just glue them together and build up a base, because you've got to have some means out here and out here to clamp this to a table. You can't just start routing it right here. You got to have this fastened. But if you come in with clamps right here, well, your router base can't won't clear it. So you'll have to be beyond. You'll have to be clamping either this out this direction, or either out that direction right there. And how I do this, I actually, where's mine? Two by, yeah, mine was a 2x10. It's about this wide. And what I do with this, I go over to my 15-inch drill press station, crank the deck down real low, and I just set it up on the drill press station, flip on the drill press light, hook the vac system over there, because see, the bit is going to be cutting in this direction, so it's going to be throwing all of the debris in that direction. So you can have your vac system back here catching the bulk of the dust or debris, and then you're clamped back here atop your little drill press deck, which your drill press deck is probably, yeah, it's your drill press deck is not even as wide as that right there, but as long as you're up under that, balanced, and then clamped back here, you have an exceptional workstation that is extremely safe. And then the only thing you have to do is just guarantee that you keep your hand planted on that left side. Obviously, keep control of it, but the most important thing is to not let it tip. If you let it tip, that bearing might not save you, and it might get you in trouble. So it works. It works exceptionally well. It's very safe. So if you've worked with a router before, then this ought to be a breeze to set this up. And you've probably already done this before in the past. But one thing I did not talk about is the importance of having this little heel, sacrificial heel on here, because this started out as a piece of S4S poplar that actually matched the S4S heel. And then as I cut into it, then I started just sacrificing that material. But what it did, it just gave something to guarantee that the bearing has something to ride along as you're entering on this side. See, it's turning this way. So you make contact with your bearing right there, and then you go into your work, and it guarantees a beautiful cut. If you're running slow, just be careful about tear out. I did not do any CA glue penetration in the end of this material, but Limba is really bad about tear out. So you wouldn't want to go in with a real aggressive first hit. Go in with a real sweet, gentle, easy, slow cut, and then make certain you're doing pushing cuts. Don't do climbing cuts. So, okay. So, and you're thinking, well, you can't do the other side. Obviously, that's true. And you couldn't, because this is tapered, unless your jig was tapered. And that's what I meant by in one of the videos. Don't worry about having a tapered jig. You're just machining one side at a time anyway. And in case I forget, some people would say, what about warpage? Because you run the risk of, if you relieve a little material here, and if you don't go over to this other side and relieve a little bit of that material in conjunction with that, you run the risk of twisting. That's kind of true, but your wood should be so incredibly stable that you're able to make this complete pass, and I mean finished. And then, obviously, then break it loose, and within just minutes, you're actually going to the other side. Now, if it was going to warp, based on that right there, I would say you had a wood that was not worth using as a neck, and you just lost a lot of time building a headstock and doing all this layout. but at least you discovered it very soon in the build that the neck was a piece of you know what. And thank God you discovered that, because it's better than shipping it to a client in the UK and you get that phone call from them later on telling you that, oh yeah, this is great, but my neck just warped. And I've only had one neck that warped, not after as I was building it, because see, if you build your necks like this, a lower, you're guaranteed that if I can build this lower and it stays perfectly true, straight on all axes, then this baby's never going to warp. I got the inside of that truss channel sealed with nitrocellulose lacquer. All this was epoxied in. I just machined off the entire neck, and it is not relying on a ebony fretboard to keep it nice and stable. Then this is a guaranteed guitar neck. This will there's no way this would ever warp on you, because if material is going to warp or be problematic, as soon as you machine it or do any sort of work like that, it's going to reveal itself immediately. And what spooks me is sometimes I've never seen it in any of my neck building, but when I used to do a lot of cabinet building, if I was working with material that I wasn't sure the age or it was always kiln dried, but stuff would twist a little bit or bow or cup or something. Then a lot of guys would say, "Well, don't worry about it; it will revert back." Well, I don't want to rely on the possibility that something is going to revert back, because it might revert twice. It might revert back to correct, but then it might warp in the future if it ends up going to Louisiana in a really moist climate or something like that, or you build it in a really moist environment and then you ship it to Arizona where it's really dry or something like that. So all the importance of working with luthier wood. So, okay, so what did we do? We machined our treble side first. Now we're going to flip this over and we're going to set up the jig to machine the bass side, which is going to be S4S, or it would be like S2S now. So let me pause, set up, and then we'll continue the discussion. Okay, so now you have flipped the whole neck over, and this is what I meant by, if that's your drill press deck, that's about the only area that is holding anything. So odds are unless you're on a long table, because you may not be working off a drill press, but if you're working off a drill press, then you're going to need a long enough jig to allow your router to pass by. But if you're working on a flat table, then all you'll need is just length to clamp beyond your routing location. And keep in mind, probably the most important thing, I don't know if I mentioned this in the discussion, but when you've got your neck lower, which was S4S, at a minimum, make sure you come up here at the very, very top edge and do some very close proximity mark work. And then once you install that on your jig, and you've guaranteed that you're flush, then you know that once your bit comes across here making these final passes, if you can look down with a magnifying glass and see a little bit of pencil left, then you know that you haven't lost your neck. But if you look down and you've radiused off an eighth of an inch of your jig, and I'm not laughing, but I've never done that. I wouldn't do anything that stupid. But if you got in a hurry and you dropped this bit too soon, and you radiused off a bunch of your actual jig material, then you probably lost your neck. Or at a minimum, you screwed up the taper on it. So then you'll have to start over and make the determination of, well, maybe I was planning on going with a 1 3/4 inch wide nut, but now I'm going to be going with just barely under 1 11/16 or something like that. So anyway, work your way to the finish line. But with with this configuration flipped, and see, this was on the other side, basically like this, and now all you do is just transfer it straight up to this side, and now you are and that'll be cantilevering back there. But now you'll be fastening this. And the way I do this, I have tile screws that are permanent screws that I'm able to do real compressed torqued fastening. And I've got a screw hole in this location and a screw hole up here. In other words, I fasten it to my lower, and that guarantees that there's no movement or there's no additional clamps in the way. So now you're ready to, and I won't be able to put that up there because it's not, well, I'll tell you what, let me pause. No, never mind, because I need to be able to slide this up here. So it's the same process. You're having to guarantee that you're stepped off about 1/4 of an inch to 3/8 of an inch, and as long as you've got the large base, you'd be safe to set this back probably 5/8 of an inch or so. But that's not necessary because the router bit is on. Well, I'll show you exactly where the router bit's going to before it makes contact. That's the magic number. So if you didn't have a problem hitting that, then 1/4 of an inch. But if you set it at 3/8 of an inch, you'd have to lose the neck in order to start getting. Well, no, you would never get to that. Okay. Hope that makes sense. And see, it wouldn't be necessary down here. Well, no, I'll take that back. I'm contradicting exactly what I just said because, as I said earlier, we got to have this platform for this to cantilever to support the base and to keep the router from doing any sort of crazy tipping in any direction. So obviously this thing is much longer, but then once you get up here, by this being higher, if it was not raised, I would be forced to stop in roughly that location right there because my router base would be beginning to make contact with the flare out of the headstock. But since I wanted to take it as close to the finish line as possible, now this permits me to actually go far enough to actually destroy this thing if I wanted to, which we don't. But it allows me to actually. No, I'll take that back. Never mind. I apologize. Okay, is that on camera? Yeah, that should be an excellent. This should be an excellent video because the design of the Explorer, and if I'm not mistaken, I think even the 3x3 sided typical like the Les Paul, the Gretsch, those type guitars. I think uh, the ear on the headstock will force a stop at that location right there, and that's exactly what you want. That's a very safe location to stop, and it's right there because now once you remove this, you're literally only having to shape off just that little small area right there and then blend it into this beautiful machine profile back here. Okay, and if you want to know, I've actually done this before where I took a router bit and I'm going to try it a little bit here, do a little bit of scraping. You could do a little bit of scraping if you want to. According to the grain, you could kind of push into it. I better stop because I don't want to screw anything up. But you could do a little bit of scraping if you wanted to, like that. Look at me, I've already created waste on my cat fur. Okay, so anyway, trust the machine. And here's a little trivia for you. This will blow your mind. Even if this neck does not make perfect contact with the flat surface behind it, if it floats a little bit, don't worry about it because the router bit is going to follow the perfectly straight line flat that you created before you put this on the jig. I'm not saying you want it in a bow or you want it funky. The most important thing is that you're flush here and that you're flush. And see, I'm actually low. That you're flush right there. And if you're flush right there and you're flush right there, it doesn't matter if this flared out a little bit. I'm read between the lines, but if anything, a good neck is going to be very close to it because the router bit is going to follow the neck. And this will blow your mind. Even when I'm doing fretboards, as long as the fretboard center line is perfectly flat, you could actually take that fretboard and put it on a jig that has a bow to it, and you could machine the radius in that fretboard like a basketball, you know, not that extreme. But then once you glue it down, it flattens out. So that kind of blows your mind. I'm not saying you want that, but there's certain things that you can do and get away with, because basically with this, that there's certain things that you can do that will self-correct themselves once they are fastened atop a perfectly flat surface. Because the whole idea about this is, with this tool right here, I'm not trying to get this neck 100% finished. That's near impossible, if not impossible. I just want to get the bulk of all this crap done so that when I'm actually building 4 or 5 guitars within a couple of month period, I'm not spending 2 days on each neck wearing myself out. So check the time. 30 minutes. Man, this would be a good video to just stop right there if you want to know the truth. And let me think about that. I may do that. Let me pause and think about what I may want to talk about, because I've noticed in my videos, I'm trying to provide way too much information in one session. And even when I watch them a second time, it's like, man, they put me to sleep. It's just way too much information. So let me pause and think about what we ought to talk about, and then we'll go from there. Okay, at this point, the reason I had mentioned you want to do the treble side first and then the bass side last is because if you were working with a 7/8 inch radius, you would be guaranteed that the bearing would still be staying atop the center line. Even if that center line begins to start radiusing off a little bit, you would be guaranteeing that you're staying on that flat and not losing the profile. But if you come in here with a 1 inch radius, well, 1 inch radius is a 2 inch diameter. And the diameter would be the distance from here to here. So once this neck goes below 2 inches in width, you've now gone beyond the 2 inch diameter. However, the cool thing about these bits, the bearing and everything, you can go beyond it. You can go beyond the 2 inches before it starts cutting into your upper part up here and creating a step. Now, if it does create a step, I should be able to explain this without blowing your mind or making you think I'm crazy, but you've created, okay, from when you look down, when you look at this neck from a longitudinal standpoint, regardless of what radial you're on, you're going to have a flat line from here up to here, from here up to here, in the middle from here up to here. It's all flat. It's just convex radius. But if this bearing gets down here and starts cutting, well then I can assure you you're now working from a center line that is no longer 17 millimeter wide, thick. You're now, and what's going to happen, you're going to create a step into the neck once you go beyond, more narrow than 2 inches. Now, is that a bad thing? Yes, it can be. But if you engineer it on the front end where maybe you anticipate the step, once you make this pass, PASS, your final pass, and you see that real microscopic step right there, it's no big deal, because all you do now is you're going to come in with your long block work anyway, and you're going to be sanding, and you don't ever want to just sand straight like that. You'll start creating flat spots. But when you're doing your sand work, you're going to want to roll you're going to want to roll it back this way and roll it back that way, and then turn the neck around 180 degrees and sand this way and roll into it, sand down the middle, and then roll. In other words, you're blending everything that you machined into points that you had to come in and chisel out or rasp out or shape out, so that you obviously have a finished neck. And you might be thinking, well, that's obvious. Well, yeah, it is obvious if you've done it a few times and you've thought through it. But but if you came in with a real flat radius bit and you had a 1 5/8 inch wide nut location up here, I think you probably would lose your neck. I think the bearing would be riding so incredibly low on that narrow neck once you got up here that it would probably step in tragic fashion. And that might not be a big of a deal if your neck was a millimeter too thick anyway. Does that make sense? Because you needed to lose that material, and now, if anything, you've got a beautiful flat up here, or a compound. Well, yeah, it's a compound radius flat. That now you have a point that you can work all of this area over here too. So I've never done that, but I'm just saying, just know when to either engineer your lower, right, excuse me, right up to it's a point of no return if you go too deep, or lose the nut width and stuff like that. So just process through a lot of this from a thought standpoint, because once you get this lower clamped to this jig, you don't really have to think anymore. The only thing you have to think about is making certain that you don't get this too low, but don't panic and leave a eighth of an inch flat up here, because you left way too much material in your neck. Okay. All right. Now I can pause and think about what else. No, I probably don't even need to pause. I'll just flip it over and probably just finish the neck. I don't even know if I'll do any sort of fitting to the body in video. I may, but we'll see. But one thing that at this point, obviously you're ready to relieve it from the jig and do the final shape work. But basically what I do at this point is just fasten it to some sort of table and start doing exactly what I just said I was talking about. Like on this open edge over here, you could go ahead and do a little bit of sanding. Let me back up. I would take it off of the jig first and just play air guitar with it and kind of see what it feels like, and then make the determination of how do I want to finish shaping it. See, my lower jig for machining my neck, it's out of a I think it's a 2x10. Yeah, it's a 2x10. So that means it's 1.5 inch wide. What does that mean? Well, that means that okay, let me just do this. Let me take it loose before I screw something up. What I'm talking about is you're getting ready to start doing all your hand shape work with either your handheld drums, like from your oscillating sander, or either chisel, where you'll be coming in with an actual chisel and actually, where you'll actually be coming in with a chisel and hand carving that off. And then, yeah, I'll talk about this in a moment, but because you've made your target lines to make certain that you don't go beyond that stuff. But at this point, I'm going to get this off the table. And I don't think I've got any 2x4s that are nice and clean and presentable. So let's just say that this is a 2x4. And I got this from Robert Benedetto. This is exactly how he built his necks. He had a real large I should have said 2x4, like a 2x10 or something like that. And then he was able to put this atop that, put a clamp back here, and even out here, it tapered up like that to meet the profile of the headstock, so that he could then clamp up here, and all of his clamps are out of his way. And now he was able to sit here and do his final blending. Rasp. Micro, you don't need a large rasp. Just go to Woodcraft or go online. These are made in England. I know they were made in England, but I don't know the name. It might be a Sheffield, but you can still get these at Woodcraft. And I think they're maybe $40 for a set of 3. I've had these nearly 30 years. So I would have paid $400 for them based on what I've been able to do with them. I got the round needle point. I actually broke the point off of that. It was even smaller than that. the triangle, and then the flat with a taper, like a teardrop, but then it's radiused on this side, so I can do really, really beautiful blend work right here. Because I'm right-handed, it works great for me to look down on it and work all that in. And then when I get to this point back here, then I'm just working this flat in. And you want to make certain that you do this before you do any of this real fine finished sand work, because the whole idea. Oh, I'm sorry. I thought the camera cut off. Let me make certain the camera didn't cut off. All right, we're at 40 minutes and 39 seconds. I should have another 20 minutes of time. I may have just gotten a text or something. But the whole idea is you've machined fairly close to the finished neck, so you really shouldn't have to do much, if any, sanding back here at all. You will. I shouldn't have said it that way, because see, I can feel the flat right there that I've got to blend in, and even the heel, I've got a flat right here that I've got to blend in, and I'm ready to take that off now. I'm pretty certain, but the whole idea is that once you're up on your jig, now you're just blending this headstock into that neck, and then you're coming in and doing your final sand work. I like the aluminum oxide 120 on this, because I want to go at it with a kind of a light touch. I don't want to have to use a 220 and have to push really hard. I like the 120 because once I've done my chisel work, now I'm ready to blend that very quickly, and then start defining. Just start defining the blend from the lower here up there. But one thing that you can anticipate happening. Oh, this is important. Um, when you do machine every bit of that off, it has every neck I've ever built. They have a tendency to just kind of relieve down a little bit. I'm exaggerating when I say they relieve down. They relieve down in a very smooth, real gradual compound radius flat, and they typically drop about, I'm not kidding and I'm not missing my number here, they typically drop no more than a 32nd of an inch to roughly a 64th of an inch. Don't freak out and try to come up here and start sanding all this flat in order to try to redefine the flat. When I say it's so minimal, it is so minimal that all you'll have to do is just do a very small amount of forward relief. See that's neutral. So if I turn just, okay, I'm neutral. I just made contact. Go about another, maybe another eighth of an inch. And now and I can just look down and guarantee you, yeah, it's perfectly flat. So let's back it off to neutral, and let's see how close it is to flat. I think it may be, this one may be flat. But what I'm talking about is typically, yeah, I can hear that? Okay, so what that means is the neck has naturally relieved down a little bit. And what caused that? Relieving all this material off the back. When you relieve material off the back of a board like that, it's going to uh, just move in that direction. I'm not going to call it a bow. It's not a twist, and it's not a cup. It's not really warpage. It's just relieving back, because the molecular structure of the wood, I guess, is what it boils down to. But it's nothing to fear, because you'll be coming in with your forward adjustable truss rod. Put a little bit of tension on it. I'm truly splitting hairs here. This is not even very important at this point, but I do want to get this perfectly flat. Yeah, I'm perfectly flat now. Now, any shape work I do back here based on a lineal cut is perfectly true with the flat surface that I've created. Even if I forgot to do that, it's no big deal. It's so close. You are so close to the finished neck right there. It's not going to be a problem. And as I mentioned, let me get this table cleaned up a little bit. I've never seen anyone build a neck this way. Even Robert Benedetto, I didn't see him build any of his necks this way. The way he built his necks, he had a board like this. It was tapered. He glued his fretboard down, and his fretboard was radiused. He finished that fretboard, then he installed his frets, and then he shaped every bit of this into that fretboard, and that's fine. That's how probably 95% of the guitars are built. I've never seen anybody do this. Am I doing it to be arrogant or anything? No, I'm doing it to guarantee that I have a lower that will never be problematic. And if I have a client that wants me to provide them with a 1950 something replica, pick your poison, I want to be able to, but because they broke their headstock off, but their fretboard is beautiful and all original, then you keep your fretboard, you keep all your broken neck, and let me just send you this lower, and it might be X number of dollars, which would seem expensive, but it allows you to salvage all your beautiful vintage stuff, even the overlay. And then I know that if I ship this to wherever location in the world and it stays straight, they're never going to have a problem when they come in with their vintage fretboard, from the 50s, and then they glue it down or have their luthier glue it down. Okay. So to me, that's when you're getting into the world of doing like master level work, when you're getting pretty close. All right, let's look at it into the body a little bit. Let me check the time. Yeah, that spooked me a little while ago. I guess I got a text or something. But typically when I'm doing a video, I don't think it's supposed to interrupt you. Or I might have got a phone call. But it sounded like the phone cut off. And I'm not going to talk about this at all other than just, well, I'm going to talk about it a little bit, but not much. Let me do this. I'll always plan on the body falling, because these things, man, they can get out of control really quickly. Okay, so there's our initial fit. Put it on the edge of the table. Yeah, just get it where it needs to be. See how I'm still thicker than the body. Man, if I drop this thing, it'll be game over, because everything over there on the right side of the table would just destroy this thing. It's loose enough that I'm not fighting anything, and I know that if I've got a beautiful fit on my pitch height and my roll axis and my yaw axis and all that jazz, which I've already engineered out, I know all I'm doing now is just getting ready to clamp, glue it together and clamp all this location in. And you can even see right here how the body is thicker than the actual neck. So once it all glues together, all of that will be beautiful once it's sanded out. And I got to tell you, this was bar none dumb luck that little proximity figuring right there matched up beautifully with that little figure work right there. And it's not from that location, but it is crazy how that worked out. It's pretty cool. I hope that's on the camera. But now all you're doing is just make sure nothing blows apart. Now all you're doing after it glues together, you're just shaping all that by hand. And I basically would be coming in with a flush cut saw maybe. I have a little specific router set up with a dovetail bit on it that is something that allows me, I can put that little router up here and I can come in here and I can route that off and it'll be flush. And I won't damage that material back there, but it'll shave off the high. And that way I'm not coming in here with a with a saw trying to cut that off, which you could do that, but you run the risk of tearing your body up. And this body's basically finished. I can't risk that anymore. So, okay. We'll talk about pitch. Yeah, let me look at the time. 50 minutes. I probably should have stopped, but if you're still here, you're definitely either crazy intrigued or you fell asleep and you just woke back up, or you came to, as a buddy of mine used to say. I'm not gonna start talking about Jimmy. Jimmy was a crazy cool guy, but he had some problems, and he was talking about, no man, I didn't wake up, I came to. But anyway, if you're waking up or if you're coming to, we're talking about building a black Limba Explorer replica. And basically, at this point, all you're doing is, before you're getting ready to glue this thing in, is you're just guaranteed that you have this pitch, the appropriate pitch. And what is that magic number? I've already covered it in past videos. After it has a fretboard on it and it's all said and done, and this, if your pitch is appropriate, you should be able to lay a straight edge across either this neck as it is and hit a certain target. Here's the numbers. Here are the numbers. If you don't have the fretboard on here and you're getting ready to, let me just put the C clamp on. I don't have time. I'm gonna have to stop talking because this is way too technical, and I don't want to rush this. But if you put your C clamp up here and you caliper tighten it down, you've got a little medallion on the back protecting your wood so you don't crush anything. And you go in here and you have this clamp together. And now if you run a straight edge atop this neck that we know is now perfectly flat, with all that clamped in place, the magic number back here at the bridge location is 3/8 of an inch. If you are less than 3/8 of an inch, you are going to run the risk of okay, let me go back here. I think I can cover this fairly quickly. If you're 3/8 of an inch or less, that'll be fine if you're not running a pick guard. If you are 3/8 inch or more, that'll be fine. I'm talking about this height from the top of the body to the bottom edge of that straight edge once this is all clamped in place. If it is 3/8 of an inch or greater, that'll be fine as long as you have pick guard material, because that pick guard material is fairly substantial. But you don't want that bridge coming out of the body too much. I've covered this in all the past videos, and we've already talked about this in enough detail that you ought to know the importance of hitting a finished guitar where the D string, the the G string is basically exactly 11/16 of an inch off the body. Whether it's to the center of the string or to the top, it's close enough for rock and roll. But that's your target. If you hit 11/16 of an inch string height at the G string, then that's going to equate to a 50s Explorer, a 50s Flying V, or probably what do they call it, the little Junior, the Les Paul Junior, something like that, or the SG. That's going to feel like this product right here. If you get it higher or lower, then it's going to change accordingly. Okay. All right. I probably shouldn't have started talking about that because that's conversation for another 3 hours worth of, or that's information for about 3 hours worth of more information. So what do I need to talk about here as far as that goes? You're just working all this in, and I'm sorry, I should have stayed on this neck, but basically you're just beginning to blend these flats a little bit. Don't round over too much. Try to keep everything very flat. And yes, you can sand this with a round as long as you don't let it turn off of that line. Stay with that line, and you can actually use the drum. Because when you're up here blending all this together after you've chiseled it down, then you're just wanting to stay and transit. I've already covered that. You're just wanting to transfer that flat. And you'll lose this heel very quickly if you're not careful. And I would say probably at this point, don't do any shaping on the heel at all other than some of this flat transition here in the middle. And that really needs to be done with a 120 aluminum oxide atop your Stuart McDonald maple block that you bought about 30 years ago. And now you're able to start rounding it over. All I'm doing is blending that flat into the side, and I can still feel it. There's quite a bit of work left to be done right there. So I would say it's okay to do that, but don't try to start shaping this heel until you get it glued into the body. Okay? And that's how you build a guitar. All right, I'm gonna pause, get the table under control, and then I'll try to figure out how to get out of this video. Okay, I want to cover a few things here and in the video talking about before you start doing this final sand work. And I'm going to give you some dimensions. I've already covered this a little bit, but your target is 17 millimeter. We're just talking about the lower right now. Your target should be 17 millimeter at the first fret location. 17 millimeter thickness before you're getting ready to do your sanding. And then you might take off a half a millimeter and you'll still be fine, but you don't want to take off too much. At the 11th fret location, you want this to be, I think it's 19 millimeter. Yeah, I'm 19 and I'm actually about 19 and a half millimeter. So that lets me know when I'm up here sanding this flat off, it's okay if one of the first things I'm going to be doing is taking a pencil and I'm just going to be really Xing this thing up, and I'm going to continually keep this pencil close to me, and I'm going to make little notes like 19 millimeter, 17 millimeter, and then I'm going to measure it, and then before I go over here and start sanding, I know how heavy my hand can be in certain locations as I'm blending this center line to this center line up there. So 17 millimeter to 19 millimeter gives you a really phenomenal playing neck. And then the way you could start it initially is have your fretboard material that you know that drop that you're working from. And rather than trying to measure this and start doing the mathematics, we'll simply put this atop this location. And see, I've already marked the first fret location and the 11th fret location right there. So what I'm going to do here is just put that right at the edge, and then I'm simply going to put my scale up here. I'm just going to check and see if this is close to 22 millimeter. And I'm like 22 and a half millimeter. So I know that I can take a little bit off here as well. My target is 22 millimeter at the first fret and roughly 25 millimeter up here at this location. So getting pretty close. So I'm 25 and a little over 25. So I might want to be careful about not taking too much of that off. I should be okay to take a little bit off up here. So just trust, if this is the actual fretboard that you're going to be gluing atop this thing, well then to heck with the numbers. Just measure this thing right here. And then if you want 25 millimeter, then that's how much you need to take off in order to achieve 25 millimeter. And if you need 22 millimeter up here, then that will determine how much you take off up here. Okay, so you're basically just working with the material that's in front of you, and then after it's all said and done, as it's coming together, take your fretboard, put it up there, and just ask yourself, do you like what you feel? Because if you don't like what you feel right now, it's not going to improve once you get the additional fret thickness in there, and those frets will make it feel a little bit fatter than it is. Okay. So I'll end the video right there. I could go on and on and on and just keep talking about how it transitions into shaping the heel and all that stuff, but it's really just working what's in front of you, and based on, as I always say, build your own guitar. And if you want a fat, chunky neck, like a really fat, thick, chunky neck, then maybe hold closer to an inch thick up here. So that would be about 2 millimeter thicker than all the numbers I just gave you, because this one's going to end up being about 7/8 of an inch thick after it's said and done. But if you want a real fat neck, maybe use the 7/8 inch radius round over, and then just prepare to have a pretty fat heel up here, a shoulder that you might have to shape off. I've never machined one where it had the 7/8 on the bottom and the 1 inch on the top. I am kind of curious about that. I might attempt that sometime, but I know that it would cause the heel to be weird looking on the bottom. It would just require that you came in and did some shape work. And don't let that spook you right there where the miter saw went in a little bit too deep. I'd rather go a little bit beyond my cut point to guarantee that I'm not in here trying to sand this crap out or rasp that stuff out and run the risk of screwing up the corner, because I know once I get ready to put this in, if anything, it's going to allow somewhere for the epoxy to run off as everything compresses together. It will definitely be a solid surface in there once it all goes together. Okay. All right, so I'll end the video there. Appreciate you guys dropping by, and no sense in continuing to talk because I've probably carried this video about 20 minutes longer than I should have, but it's a ton of information, and I hope you'll be very safe if you're doing your router work. If you're spooked or scared or nervous at all, just get with someone who is really comfortable with the router and let them watch this video with you, and then you guys do a game plan, and then just build your neck, or maybe let them pull the trigger on the tool, and maybe they might let you do the first one or two passes, and then maybe let them do the last real critical pass cuts and stuff like that. So just be safe and build your guitar, and I will see you guys in the next video. Thanks.